Welcome to the MSDN.NET Application Architecture Review. My name is Steve Kirk, and I'm an application architect with MSDN. And today we've got a panel discussion. We've got speakers from sessions that were part of the MSDN Fast Track that are going to participate in this discussion. And just to get an idea, how many of you are, just by raising your hands, how many of you are familiar with the MSDN Architectural Fast Track here at TechEd? Okay, so we've got a good number of you. And have any of you worked with things like the reading list and so on, taken a look at that beforehand? Any hands? Okay, well, there's a few. So anyway, the Fast Track is... Okay, so we've got a substitute panelist coming in at the last minute. Thanks, John. So the MSDN Fast Track is basically a federation of sessions here at TechEd around the topic of architectural design, .NET application design. And what we've done with MSDN is to provide some pre-content, pre-conference reading lists around these sessions. We've organized the sessions around application design, and then we'll do some post-conference content, some follow-up on these sessions. So what our goal here is to give just a lot better experience to help you get a lot more out of TechEd. So let me introduce the panelists. To my left is Mike Pizzo, who's the architect of ADO.NET. And Mike's got 2 sessions tomorrow that are part of the Architectural Fast Track. And Susan Warren from ASP.NET. And Susan had 2 sessions today of her many sessions here at TechEd that were part of the Architectural Fast Track. Eric Schmidt from Web Services, who has had a couple sessions here on Web Services security and
integration.
In GXA.
Yep.
Great. And then our substitute panelist.
My name is Rocky Lethka, and I work for Magenic Technologies, and I did a session, actually 2 earlier today, but one on design and architecture, best practices, and that sort of thing.
Great. Thanks, Rocky, for
you're
coming
welcome.
in on short notice. Okay. What I'm going to do is we're going to start out with a couple of very general questions that are sort of composite questions from questions we received online. And then once that gets us going, very early on, we're going to depend on the questions that you guys bring. Okay, so we're hoping that a lot of you will spend some time at the mic and with questions for our panelists. Okay, so just to start off, application designers are faced with several choices between, let's say, the way they represent data in a distributed application, as well as ways to pass that data between the tiers of a distributed application. And we're going to look at some of these choices in more detail as we look at and address specific questions. But to begin, can the panelists give us some very general guidance on how to represent data in a distributed application, and then what are some of the trade-offs as we look at the ways to pass data between the tiers of a distributed application? So anyone want to jump right in and take that?
I'll start.
Okay.
Seems reasonable.
So we used to, when the internet first became popular, there was a lot of talk about the stateless internet. And we came to realize once we started writing applications that were more advanced than just putting up little wheels and playing chess and stuff, that the internet was actually all about state. And in fact, even the state, or a chess game is all about state, managing the state between the chess players. So the concepts of working with data and how data is distributed amongst this application, which is now partly on a server, partly on one client, partly on another client, became very relevant. And there are certainly a lot of different technologies in this area. There's XML as a general data representation. There's still a lot of data in relational databases, and I expect and hope that continues to be the case. And then there's data that's contained in objects. There's data that's contained in all other types of stores and sources, data on the client, data on the server. Once you start talking about a question like, and I get the question all the time, well, what's the most efficient way for me to use data in my application? And it's so generic, it's really, really difficult to address. But there are some common things that we're seeing. We're seeing XML being used more and more as a way to pass data between tiers in a generic manner. So particularly across the internet or to clients where you don't control the client and the server aspects of it. Because XML is a self-descriptive, very generic way to represent that data. And in fact, initially when we started seeing XML usage, that XML usage was a very proprietary usage of XML. Even the original ADO record sets, when they could write out XML, wrote out XML. It was XML. It was conformed to XML, but it was a very proprietary format. We're seeing data become more and more generic and described by XSD, XML schema definition language formats. So that's really encouraging to try to make that data more generic, more shareable. When you do have control over the client and the server, the question is, do you use your own proprietary formats? Do you use a binary format? Do you use XML? There's been work done in binary XML. There's work done with compressing XML. Really, a lot of what we're looking for is rather than have one-off solutions for improving, remoting of one particular object as XML, really growing XML to be a better, more compact, more performant way to remote data. So I'm not sure if that answers anything, other than the fact we see a lot of XML used where you don't control the client and the server components of a distributed application, and actually XML used a lot even when you do control the client and the service. And there's performance and robustness and security trade-offs there, but more and more we're seeing XML as a very common format for moving data between tiers.
Well, I'd make some comments about web apps, web UI, and so forth. I get a lot of questions about what kind of object should the data be in while it's still in an object format. I think XML as a data representation is pretty interesting, but people need to manipulate it, work with it, deal with it. And there's, in the web at least, an interesting thing that happens where the data sort of jumps out of being data and into being a presentation of the data. It's no longer data that people would actually manipulate. I'll give you an example. When you browse a product on buy.com or something, and the data that you see is data that came out of some relational database someplace, or perhaps an XML file that got transformed. But by the time you see it, it's already in the page part, intermingled with the XML and HTML of the page itself, and no longer strictly data, just something that got presented to a user. And that's a pretty common thing that happens in a web app is, while that product object or whatever it was that made the sort of the trip from wherever the data store was onto your desktop, made that trip, at some point it just sort of came out of an object and became something flat and not reconstitutable any longer. Just a presentation of that data. So the web is interesting in that respect because I think the actual objects themselves are very transient in many cases. And the real architectural questions are, when do you let an object transfer from being a real manipulatable data object into something that you don't intend to reconstitute again? And then, of course, how do you deal with the regular straight-up architectural questions of, I've got data, I need to share it between this component and that component. Do I serialize it? Do I pass it in proc? Those kinds of questions. Those tend to be pretty standard architectural questions. Where are the right places for your process boundaries? What's it going to cost you in terms of security, performance, those things largely? And they're very standard regardless of the app type. All my comments on data.
I have a little bit of different view of the world because I have my head buried in the sand on the messaging side. So Mike's more of the data guy, and Susan is the web guy, or the web gal. And
Love it.
I'm the messaging or the plumbing guy. I'm the plumber. So one of the things that was pretty obvious this week so far at TechEd, and it's actually enjoyable to get this feedback from from everybody is people are realizing that they need to embrace XML to be basically all things to all people from the components that they create. They realize that old object technology and the different types of object models that they built is not the path to interoperability between systems. So, the .NET framework is doing a lot of things for people now on the remoting side to ensure that we can have nice, compact, efficient, distributed object model, and the system, the XML serialization and the web service side of the framework is doing, great to ensure interoperability on the SOAP side. I think the main thing that we're struggling with, and this is probably the inside of your question, is what's the real programming model? Is it when do we let go of that data inside of the object from being XML and we actually constitute a CLR object and all that data is sitting inside of CLR types? And when do we throw away that XML? Whenever we know we're going to have to turn around and put it right back on the wire, whether we're doing data binding or we're going to serialize that into a binary format or we're going to create a SOAP message. And I think the jury's still out on that about what the best thing is to do, but I know collectively from all the product groups, at least these three groups right here, we're working on that model heavily. Most people are doing the right thing. A lot of our vendors and instructors and evangelists have really distilled on when to use remoting and when to use serialization. I think the holy grail in the future will be having one programming model to kind of do both. But that's remained to be seen. I guess the moral of the story is if you are using XML as that technology, to choose your technologies wisely. So you want to serialize wisely, you want to validate wisely, you want to bind your data wisely. So
I'm going to come at it, in a sense, from yet a different perspective, because I don't actually work in a product group. I'm one of the Microsoft partners here that has the opportunity to present, and my perspective, for those that don't know, I've written a couple books on doing distributed object development in COM and Visual Basic in the past, and I look at the world largely as being segregated into two pieces. There's the data-centric piece of the world, and then there's the object-oriented piece of the world. And this gets kind of blurry because you can have data objects, like Susan referred to. But those tend to be objects that have no business logic. They're just a type that represents data. So in my worldview, they're still over on the data side of the universe. It's not until you create a truly, say, a customer object that not only has customer data, but has all the customer behaviors, right? Then you've got something that's living on the object side of the world. And the rules are different, at least between these, today, anyway, the rules are different between these two worlds because there's a lot of technology around how you move data around. Moving it in XML or in arrays or in data objects or data sets or data tables. All of those things, to a very large degree, are kind of the same, right? You're moving raw, unprotected data from your database into some server, possibly out to the client, and you certainly hope nobody does anything bad with it, because when they give it back to you, then you end up having to revalidate it because it was unprotected data. And so, things like web services are wonderful for that. And I think XML is wonderful for that because it provides mechanisms to just send data around. But fundamentally, it's no different in my mind than sending it around in an array, right? So on the other end of the spectrum, and this is where I really personally get very excited about .NET, things like .NET's remoting and its deep serialization capabilities allow you to truly pass objects around on the wire, like real ones with business logic and everything. So I can from my server, I can hand my client a customer object or a sales order object. And there's no extra code really on my part because .NET does all of this for me, right? But all of a sudden now my client has a real customer object with behaviors and validation logic and business processing. And so it really enables a new type of, well, not new necessarily, but for most of us living in the Microsoft world, it's relatively new because this kind of thing was very hard to do in COM and becomes really almost trivial in .NET. And so then, so that's where the reference to being maybe a little more prescriptive about saying, well, if I'm exposing just data, and I'm exposing it to a .NET client, probably my primary concern is performance. So picking some binary format or binary protocol that's going to be fast, that might make a lot of sense. Or I've got some raw data that I want to send to an unknown client, or a client that is outside of my control, like has been mentioned, XML, obvious choice there, right? But if I'm trying to create a distributed application and I want to be able to actually move my objects around, then what you're really looking at this point anyway is remoting and using a deep serialization technology. So, but all of this is in .NET, so it's all, the options, a lot of people are very confused, and I certainly understand why.
Okay, I think there's going to be a lot of opportunities there to look at questions, some of those, to go a little bit back and forth, and as well to tie those in with questions that other people bring in, because there's a little bit of interesting tension there and different points of view, so that'll make for some pretty good discussion.
I guess the one thing, just as a crowd-pleasing offer, one of the things that I am taking personally responsibility whenever I go back to Redmond is to work with some other folks to get the white paper out that clearly codifies when to use remoting in what scenarios and when to use XML serialization. So that's one of my primary marching orders whenever I get back.
Would you care to generalize on that a little bit now?
No. I have lots of information, lots of opinions, and we will work on it.
Okay. Okay. Well, let's go to the next just general question, and we'll go from there. This is on security. So security, including authentication, authorization, data privacy, and issues like non-repudiation. These need to be demystified in order for distributed applications to be really fully useful. So here's the question. How do you secure a distributed application?
Wow.
How much time 42.
If possible, I actually want to, because I'll add on to that question in a sense.
Oh, great.
Yeah, because it was too easy.
Well, because the typical answer that we're going to get, and I'm going to sound like I'm being adversarial, and maybe I am.
Go for it.
Is this, so there's all sorts of stuff around the web, and Susan will probably talk about that, and that's good. But I personally tend to focus on truly distributed, rich clients. Right? That's my passion. I have a hard time turning my Cray-like desktop computer, because you think about that, our computers these days are equivalent to a Cray from a few years back. Turning that into a terminal just irks me. So, and especially with .NET's auto-deployment capabilities, I'm really a strong advocate of putting rich clients out on the desktop. And as soon as you do that, you enter into something that I've never seen a solution for. And I don't think .NET has it either, but I think it feeds into this conversation, which is it's not enough to just know who's sitting at the terminal, who's sitting at the PC. And it has never been enough, because we've had, even in the world of COM, you got your accountant sitting out there working with my application, and my application is talking to some COM plus object, right? And so we've got role-based security and everything, and so we know that Fred is safe, right? Except that Fred jumps into Excel and starts talking to my middle-tier objects without going through my client-side app. Now Fred isn't so safe anymore, right? Or you drop that to the database level, right? People can still, to this day, construct applications that use database security. So when I sign in, my username and password is the one in the database, right? So whether I log in or not depends on whether I'm in SQL Server. And then we give those people access and wonder why they keep changing our tables without any validation or business rules. And our DBAs say, well, you should have written your entire application in Transact SQL. Right? Nobody laughs. You guys all like writing in Transact SQL? I mean, that's, that was dripping with sarcasm. But I mean, so there's this, and that type of security, I'm challenging you guys, right? Because the stock answers will tend to be around role-based security and a lot of different things like that. And I'm going to say, well, those are all very important. And a lot of work goes into them, but we're missing an entire piece of the puzzle, especially with distributed applications.
Yeah. I'd also like to qualify the question to say, are we talking about a distributed application in a homogeneous environment? So are we in the Windows environment? Are we talking about distributed, heterogeneous, truly distributed, and we have to do federation?
Let's go truly. Let's expand it and include everything. Okay.
Well, how do you get your no-touch deployment done? No, I'm just kidding. I can talk a little bit of this because this was the subject matter that I spoke on this morning, and this really comes back down to the plumbing. And I totally agree. We have entirely too many ways today to invoke and create security models inside of the Windows environment. I think the .NET framework and the factoring of the .NET framework is going to help solve a lot of these problems. So as the individual products move over to a truly .NET framework and CLR-based environment, they're all going to be pushing down to a common security model. That's appears to where everything is moving to. And Mike, you can probably speak onto this a little bit more on the SQL Server side, I hope. But so that's a nice thing about getting all the boxes to have the same security model. But what we're really talking about beyond the intranet or the intra-enterprise is how to do federation across disparate systems. And the acknowledgement from the development community and from the web services world is that people believe and are committed to pushing this down to the messaging layer. So no longer are we looking about managing having problems about doing Windows management and SQL Server management and Com Plus management. We'll have different problems about how do we manage the security model inside of that messaging infrastructure. What types of security tokens should be put inside there to give access people to certain services? And I guess the good news is that now we're focusing on one common programming model. It's going to be inside of web services. It's going to be at the messaging layer. And it's going to be a lot easier for people to deal with. We're going to be dealing with XML. We're going to be dealing with SOAP. And we're also going to be dealing with open standards. So I think that'll go a long way to help the problem.
Okay. Anyone else? Susan?
Yeah, I was just thinking about this whole conversation. There's a lot in the web world, there's all kinds of things that you have to secure in all different kinds of ways. There's just the basic, who is somebody and what can they do in my application, and if we do cross the boundary between my front-end web server box and my middle tier boxes and my data tier boxes, how do I secure that path so that they get to do all the right things and none of the wrong things? That's pretty common scenarios inside of the web world. There's also sort of a new class of issues that we've been asked to look at as Microsoft in the .NET framework, which is how do we guard our secrets. In the past, that wasn't really something that you guys asked us for much help on, but we've helped you with so many other things that now you're saying, well, where can I put my connection string to my database, for example? And then beyond that, there's also the piece of code access security. How do we codify the trust between two different components, which I think is sort of the answer to your issue of my DLL. How do I know that this DLL may be invoked by another DLL and so forth? So there's a lot of stuff going on there. And it's hard to be very prescriptive, I think, about any one of those things without sort of narrowing the scope. It's a pretty big question. I think everybody here agrees that. But I think we've done some pretty interesting things in .NET to make it possible in not only web services apps and the stuff that we're thinking about with GXA and so forth, but just in the straight up Windows apps with code access security in particular, and also a lot of stuff in ASP.NET for web app security, making it a lot simpler to do things like impersonation, a lot simpler to hook into some authentication store to authenticate a user against not only your regular NT credential kinds of stuff, but, sort of roll your own, any third-party store you might be using. And also a lot simpler to carry the role information. What may a particular user do throughout the process of an entire request, not just in the page, but also any of the components that might be called during the course of that request. So that stuff all becomes a lot easier. I think going off the box is where the real challenges are. How do you secure your remoting from one box to another? And maybe web services are the answer. I don't know. But I think that's sort of the scope of questions that we deal with in our world. It's kind of too bad that we didn't also get Eric Olson, who's really a guru at this stuff, to help us out here. But those are the challenges that I've certainly faced in the applications that I've done, is, you know, finding the right ways to make sure that you can control the resources. In the web world, there's yet one more issue that's pretty specific to the web, which is it's pretty easy to exploit many well-known vulnerabilities in the way that HTTP and HTML work, and JavaScript and so forth. And so there's sort of a whole other class of, beyond what I'm thinking about in the course of my normal running application, the assets in my application that I'm trying to protect, like secure data and so forth, back on the server, what might somebody use my application to do to harm the client? And so that's another sort of whole big thing that a lot of people don't really think about until they get burned, or their clients get burned in the web. And that's one of the things that we'd like to give more thought to going forward. What can we do in ASP.NET to make ASP.NET applications somehow less vulnerable than the average web app to those kinds of exploits?
I'll throw in my 2 bits. Certainly, as the model for accessing and working with data has changed over the last, I'd say, 10 years, though it doesn't seem that long, what it means to be secure and to secure your data has really changed as well. Back in the olden days of embedded SQL, all access to your database was basically compiled into your application. And so you could know and control exactly how your data was modified by that application. It was compiled into the application. There's a corresponding access plan or procedure compiled on the database, and then those two just interacted in very well-defined ways. Well, about 8 or 9 years ago, Microsoft came along with something called ODBC. And the idea of ODBC was really to open up the database, to allow non-shrink wrap, non-precompiled applications to talk to existing data. And actually, that technology at Microsoft came from the Excel team. And I was a program manager working on ODBC at the time in the Excel group. And really, our goal was to allow the Excel application to be able to access people's relational data without Excel, when we wrote it, having to know about all the different databases out there, how they behaved, what the queries were allowable to them, the connection models to them, and all of the queries that people might want to request to those data. So we worked on very much genericizing how you access the data. Well, now all of a sudden, some of the security models or lack of security models that were out there no longer applied or became a problem. So we still see today people using SA and no password as the connection string when they connect to SQL Server, or the equivalent in Oracle of Scott Tiger or whatever you have. And so people, in a lot of ways, still have not made that jump to, if I'm allowing generic access directly to my data, I'm really opening up the farm, and I'm really enabling them to do a lot of different things. Certainly within the database, there is a well-defined security model that allows you to set up users, allows you to set up roles, allows you to set up privileges for accessing, reading, and modifying data. Another thing that people commonly use to help control access to data in the database are things like stored procedures in SQL Server or procedures in Oracle. And procedures are a good way to limit how people access and work with data. They also provide some amount of performance increase generally because it's a precompiled access plan. But what we see in the businesses today is instead of creating a client table and adding a client by going in and doing an insert into client values in all of my new client values, and instead of changing an account balance by actually going in and modifying the account balance field, I'll write stored procedures for transfer money or add client or do this or do that, where the actual accessing of the data is controlled by that stored procedure. So instead of actually giving somebody my data, letting them make changes to it, and then taking those changes and just, assuming that that's correct, I'm limiting how they access my data and the ways in which they do it. Several years ago, a guy from Microsoft named Pat Hellen gave an excellent presentation on something called fiefdoms and emissaries, and it's become legendary throughout Microsoft. And the basic idea, I think, is very sound and holds true today. The idea is that your data is your fiefdom, it's your kingdom, it's guarded. You don't give anybody direct access to that. You give people the ability to ask questions, or you publish data. So you might publish your catalog data, you might publish information about this or that, or you might allow them to make certain authenticated requests for a particular piece of data, like what is the account balance. And then you publish data outside of your fiefdom, and that data is delivered through what Pat Hellen referred to as an emissary, someone who delivered the data down to possibly a separate untrusted machine. And his basic precept is anything outside of that fiefdom is untrusted. So you deliver the data, you allow the user to look at the data, to make decisions based on that data, but they don't send you back a changed copy of that data. Instead, they make requests based on that data. I want to order this particular book. I want to transfer this amount of money from account A to account B. Again, you have to authenticate that request, and then you run your own logic within your fiefdom to actually change data based on that particular request. So we see now as we're moving to a model where people are thinking less about working with data, thinking less about whether it's represented as XML or this format or that format, to people doing business activities, doing things like transfer funds. And that's where providing functionality in true business objects that have business logic, that can validate the work that you're doing, are very helpful, because now the business object won't let you change data that you shouldn't have access to change, won't let you just update your account balance, but will let you call methods that might have effect on the data exposed through that object. But even in this case, even in the case where there is business logic on the object that you're using to manipulate that data, whenever that business logic lives outside of your fiefdom, whenever you get that data back, you want to not just assume it's correct. You've got to do some validation. You've got to authenticate that. You've got to run your own processes on that data. You can't just take data from outside the fiefdom and apply it back into your data store.
So I have one comment on this, because we seem to have come full circle, because now we've just gone from the object and back outside of the object going into the fiefdom, right? And what is that? It's messaging. And the way and what is that standards-based messaging? It's web services. And the way that you go about putting that credentialing and authorization and authentication is all about the extensibility mechanisms. And I'd probably get fired because I forgot to mention yesterday we released the first WS security spec for web services. It was a joint effort between Microsoft, IBM, and VeriSign. And it addresses this very concept. It's how you go about sticking security tokens or a credential, some type of authentication information into the SOAP message, and then understand how that to be processed on the service's behalf. So I guess the point here, I mean, if you can imagine, this isn't, I'm not necessarily saying where things are going, but imagine if SQL Server, queuing, COM+, and every other service that you end up talking to with your components, basically all they did was just process these messages, and they were SOAP messages. I'm not saying that this is what's going to happen, but you can just imagine this message is running around with little Kerberos tickets or X509 certs or whatever authentication mechanism, popping from service to service. I don't care if you want ODBC or if you want to get transaction context. The same thing happens at all of these. And by the way, if you have to go outside of your enterprise to do some B2B work, the same exact thing happens. That's what's required to do federation. So to answer the question.
So now I want to jump back in.
Okay.
Just to complete the spiral of circles or something. So now we've gone from the database back through messaging, but the messages are going to and from something, and those should be objects, right? And so if in fact we can secure the channel, right, and so we have some mechanism that we can say, well, when I put a message out on the wire, however that wire looks like, right, that there's some way of knowing that it was me that sent it and that it didn't get tampered with on the way, right? So now we start to come back around to where your fiefdom can start trusting some of the emissaries that you've created. Right? right? And this is really the trick to doing a truly distributed application, is that if you can't ever trust an emissary, even one that you created and sent out, then what's the point? Because you have to do, you said you have to do some validation when you get the data back. I would argue you have to do all validation. If you don't trust whoever you gave the data to, when you get that data back, you have to do all of your validation. Any part that you miss is a security hole that they will exploit at some time, either on purpose or by accident, right? And they will crash or corrupt your data or application. And so it's not that you have to do some validation, you have to do all of it. Or you have to figure out a mechanism by which you know that the code that they're running, that object that's running out there somewhere, is an object that you trust, and that the pipe that it used to send the message back to you, or the message itself, is somehow the one that was sent. Right? So it sounds, based on what you're saying, that at least we're moving one step closer, so that when that untrusted or unvalidatable object that I would love to trust but don't know how yet, can at least send me a message so that I know that the message came from that untrusted bit of code. Right? So now, we're getting closer, is my point, I think.
Yeah, I think whenever Pat's created his talk, and this really is a legendary talk, if you can ever get the original slides, it's an awesome talk to go through. But back then, we were really looking at data, and things like public key infrastructure and cryptography wasn't commonplace for traditional developers. And I think today, being able to create a trust model is a lot more attainable than it was 2, 3, 4 years ago. So we are going to be able to create trust models maybe on slightly trusted fiefdoms, depending how far you want to go with that. But we have a lot better technology today than we did several years ago.
Actually, that right there, that actually leads us into just the final of the most general questions, and that goes, we push the discussion outside of the firewall and talk about how are we going to achieve then, in order to make these business applications that are span organizations across the internet, how are we going to achieve exactly once messaging? And then how are we going to also do what is the logical equivalent of a transaction between these organizations? Okay, what's the plan for that, and how are we going to go forward?
It's all about plumbing. I'm not being facetious or trying to make a joke, but it really is. If you're following any of the GXA information that we've posted on MSDN, or have gone to any sessions that are GXA related, you'll see the GXA composability stack. One of those is a section or a module on reliability, and that is the first tentative once and only once order delivery, and there's some other various mechanisms to create a reliability model. Where does that get composed? It gets composed at the messaging layer, and it's acted upon the actors or the services processing the message. So that's the model there. And the other question was about two-phase commit. That work right now has internally has I believe less traction than, obviously, we just worked on security, and if you look up the stack, there are some dependencies that a two-phase commit model would require in the GXA stack. But we are looking at a two-phase commit model, and obviously we have in the past, supported a compensation model through tools like BizTalk Server, which has very nice compensating transaction support. How you go about in taking that compensation information and get that into a standards-based messaging infrastructure that can be put inside of SOAP. A good example, back to BizTalk Server, is they have the BizTalk framework, which is a standard for BizTalk Server, but it's not a standard for truly federated and distributed transactions across non-BizTalk Server services. And in the future, whenever that model gets embedded into GXA and all the web services have adopted the GXA standard, then we'll be able to do either a two-phase commit or compensating transaction model.
So how was that for a warm-up?
I'm warm.
Yeah, okay. So now we need to depend on you guys, okay? Let's let's start bringing questions to the microphone, okay, and going from the very general questions that we warmed up with, let's start getting to some more specific questions, or more general questions. But now is a great time to bring those forward, and we're actually hoping to spend a good amount of time on those questions. So.
Hello. I have a question about an application that we are just putting the finishing touches on. It's about a 60-page ASP.NET app, very heavy pages, very interactive with the client, lots of client-side validation, SQL servers in the back end. The actual architecture is very much like the Duwamish 7, and right now it's running on a single web server. We're sort of doing some load testing and QA testing of the app, but we've already begun thinking about, okay, what's next? And so the natural question is, where do we go? Do we add additional web servers with the components running on them, or do we break out the data access components and go to another layer, physical layer, that is? We have about the Duwamish 7 is I think it's 3 or 4 logical layers. There's a data access, there's a business logic,
data facade.
And a facade, correct. Yeah. So it's technically 4, I guess.
Yeah. So it's an interesting question. I think in the world of DNA in the past, we really sort of urged people to move their component layer off of the same box as their web front end. But there's a big performance cost in doing that. And you're finding it today. You're running your UI, even though it's logically separated, in process with your components and also your data access logic for that matter. And so you'll pay a big price, performance and scalability-wise, if you decide to split those out, because you're going to be making a remoting call to those guys, which means your objects will be serialized. Some folks do it because they want to share those middle-tier components, the component logic, with other apps, and that's a good justification for doing it. If you're not in that circumstance, we find lots and lots of people now are sort of making the choice to scale sideways and have multiple web servers with basically the entire stack running on each.
Actually, can I?
Yeah.
I want to ask you a question.
Okay.
So you just gave a justification that the reason that you might separate that out physically, like onto a separate machine physically,
Right.
is because you want to share that code.
The component logic, yeah.
The component logic.
Yeah, the components.
But so you're going to take a huge so I'll be challenging,
So,
right? So
yeah,
you're going to take a huge performance hit just to share logic that you could have just cookie-cuttered stamped out onto those servers in the first place and let them run in process.
So
Right?
to share
you're
that
actually
logic with other applications.
So you're trading a deployment versus performance is what you're saying, right?
Not exactly.
Okay.
So the times that I've seen people really make a good case for splitting the component logic off onto another server is it actually comes back to these objects like you're talking about, the customer object and the whatever object, because they create a customer object once, and they have a server, a set of servers that know how to interact with the database to do the right things against the data that represent the customer. When you add the next application, it sort of works better in some cases when you have lots of applications all consuming that customer object to go get it from the same pool. So that's the justification that the times that I've seen it work for folks, that's when it's done it. But the majority of the time, we see that people are now collapsing the physical separation between the layers and scaling sideways, having 5 web servers with a full stack on each, instead of having a separate cluster for application servers and a separate cluster for data access layer. And then very often putting it behind a DMZ. So you have something in front of it to protect your business logic behind so that you have IP isolation from the web.
This is a hosted application, so it will be people from, it's basically a subscription-based application, and people could be coming in really from anywhere. And it will be firewall protected. But if we go to the model where we're having multiple servers with the full stack on it, are there can you comment on specific things within ASP.NET that we need to be careful about if we're, say, using load balancing with Application Center?
Sure.
And are there gotchas with different types of techniques that we may be using, say, for passing state between page to page, or perhaps with, I'm going to say, for instance, I know in your earlier session you were talking about passing. You were talking about passing information from one page to another, and I can give you an exact example.
Okay.
We have a page where a person puts in a bunch of criteria, search criteria for real estate, and the application basically takes what they filled in, builds a big XML document based on what they selected, and passes it to a function that hits the database and comes back with the properties that meet that criteria. Now, the way we're currently doing it, because we had some issues with getting it to work the way you're supposed to do it, which is by a public property on the form, and then the other form reads from that property. We had to actually stuff it in session. I know. We plan on changing that, but can you comment a little bit on some gotchas when you go to a multiple server scenario where you may not end up on the same machine with that second request?
Okay, so yeah, sure, certainly. Hey, can I see a show of hands? How many people think session state is evil? A lot of you think that's true. We've done some work in ASP.NET to make it be less evil. You can still hurt yourself if you abuse it, but it's quite a bit better. And some of the issues you have about saying, hey, we're using session now, and how are we going to migrate to 2 boxes, we've solved that in ASP.NET by making it possible to put session on a server, one server for the cluster that's shared. It could either be in an NT process, service rather, or in a temp table in SQL Server. So you have this ability to still web farm and have session state at the same time. But to answer some of your questions about specific issues you run into when you serve an application on a web farm, there are just a handful of small things. They tend to be, and I've done this, by the way, so in the real world, so I've run into them. There tend to be just a handful of very small things. One is session state, and that's very easy to, with a configuration setting in your application, to migrate the session off to an out-of-process session store. So that one's down. The second one is view state. Now, view state these days, by default, and by the way, no one should change this default, okay, is encoded or has a MAC appended to it, a little hash appended to it, so that we can validate that it is indeed a view state that has not been hacked. Otherwise, view state is pretty vulnerable. So it's good to leave that MAC on. But the hash is generated using a key, and the key by default, when you install ASP.NET, is auto-generated. So there's just one little step that you need to do in the configuration of each of your servers on your web farm to ensure that they share the same encryption key for view state. So that's one little step. One other small step that you'd need to do if you're serving mobile apps. Mobile apps require a very similar kind of small change where in configuration you set a consistent path to the application for each of the servers on the cluster. And literally, that's it. So when I've deployed apps, the apps themselves stay exactly the same, and I set up a new server, I set these couple of keys, and I'm good to go.
No gotchas with caching objects?
So the gotchas with caching objects are there. It's sort of the jury's out whether it's a gotcha, but you will, if you're putting things in cache, for example, output caching pages, keep a separate version of that cache on each of the servers. So very typically what we've seen with customers who've done big deployments already with a lot of output caching is that they have more or less the same things in cache in most of the servers because with any large app, anytime you go over 2 boxes, that's a pretty large app, statistically it's going to be the same things in cache. So you do really literally get an additional copy of your first server when you make your second server, and it has the same things loaded in memory as the first one did.
Great, thanks a lot. Just a general comment, Visual Studio is awesome.
Thanks.
Over here.
Hello. Going back to the earlier question you guys were discussing, you only talked about maybe part of the answer, why you would keep the physical layers separate. Deployment, ease of manageability, and layered security. I mean, wouldn't that be a very large part of the equation? Why you would choose to keep them separate? Especially like a large enterprise customer. I mean, I work for a large enterprise. If we have to deploy a solution across, say, the entire country or entire world, all our offices, we've got to be able to do this where ops can work with development and all other groups. And it becomes very hard trying to collapse them and just use different web servers.
Right.
So,
I'm sorry.
Oh, did you want?
I was just going to agree that the business reasons for distributing an application are very often the driving reasons.
So, obviously, having had a fairly strong opinion on it, I'll jump in because you've tossed out three things, and one of them being layer security, right? And that one I agree with entirely. Just hands down, if the fact is that you need to have an external firewall and then your web servers and then an internal firewall, I'm with you entirely there, right? That is an obvious, yeah, you need to physically separate your tiers. In the world of ASP and COM, I probably would have agreed with you a fair bit on the maintainability and the deployment. But in .NET, I would start to disagree because the ability of .NET to do some of the deployment and how trivial it is to deploy things in .NET, comparatively speaking anyway, I think tends to negate a lot of the reason that you might say, well, is it worth a 40 to 50% performance hit? Because that's really what we're talking about, right? You come in with a page request to the web server makes another page request. Really, that's what a web service is another page request. So for every page request, you're making at least two. So by definition, you take about a 50% speed hit. Is it worth that to avoid having to X-copy some files out to your servers? I mean, that's really what we're talking about, especially when you toss Application Center Server into the mix, right, which can help you deploy all of these files out. And on top of that yet, just how often do you update a component without updating a web page? Or vice versa? I mean, honestly, just think about that. And if in fact in your application you're updating DLLs like crazy without ever updating your pages, I envy you. Right? But the reality is that usually if I'm updating a component, I'm adding or removing a property or a method. I'm doing something, right? It probably affects at least one page. So I already have to go touch every web server in my farm, right? So it's what's the difference between copying an ASPX file and a DLL? You know, it doesn't matter, is my point.
I'm still not convinced, but I just wanted to make sure I brought that up because we only talked about what are the advantages of collapsing them. We hadn't talked about what are the disadvantages of those, and vice versa. Thank you.
Thank you. I'm not sure who is next, but
I think I was next. Hi, in regards, we're having some discussions about performance and best practice in the .NET space, and I'm thinking back to the DNA space, and one of the things that we used to further this discussion was Fitch and Mather, and it had a huge impact on the way that I know going to previous TechEds were done, and really gave us, I mean, beyond kind of a PowerPoint perspective, it gave me a lot of hard numbers I could go back to. We spent a lot of time in some of these sessions with, perf mon up, and we were tracking how things were going, and it was very hardcore technical. Here is the impact and results. And I just haven't seen anything in the .NET space being produced like that quite yet, something that I can use and say, pros and cons aside, I can actually say, here's the hard numbers coming from a sample application. Is there stuff like that that has the published results that, I mean, like the iBuySpy stuff and all that, it's definitely not, I don't think it's focused in that same kind of space.
So are you familiar with the pet shop application that we did in...
Oh, the J2EE switchover
comparison thing? Because that has quite a lot of numbers and also a lot of analysis of the performance. Is that what you're asking for? Is performance numbers?
And is that kind of from Microsoft perspective, sort of? But also you got best practices too, and I wasn't sure if they felt like that was sort of a best practice implementation, or if that was, I mean, because they were definitely going for speed, for comparison to the J2EE platform. And I didn't know if they wanted us to take that, and that was kind of a Microsoft recommendation for moving forward some things to do or not.
Yeah, I understand what you're saying. I'm quite familiar with the Fitch and Mather app that we all used for years and years. In fact, I think that there were like 2 million downloads of Fitch and Mather, some really, really large number. It was pretty influential. And the same folks who wrote that app, the Vertigo guys, did the iBuySpy stuff and also the Pet Shop stuff. But I think the missing piece is probably the sort of combination of the architectural guidance that we get today out of the samples that ship inside of Visual Studio. Like Duwamish, for example, has a lot of architectural guidance information in it, combined with here are the hard numbers. But I remember the TechEd or whatever you were talking about, where we had all the PCs on stage and we were doing the numbers and stuff. And as I recall, we didn't have to do a lot special to get great numbers. It just sort of worked that way. And having been involved with the Pet Shop thing recently, it was also true. It just sort of worked that way. Now, we did go through and make sure that we had output caching on in all the right places and view state turned off in all the right places and stuff, but just things that I would hope that everybody would do for their apps. When it came time and they're close to deploying, they made sure that they had everything set well. The virtue of that app is that it's relatively simple, and by the way, it's pretty much iBuySpy store. There's not a lot different there between those two apps. So in terms of seeing sort of a bare bones app and getting implementation out of sort of implementation guidance out of it, that one would be a good one to take a look at. One more thing I'd say, remember all that cool, sort of load testing we saw around Fitch and Mather? Visual Studio now has the load testing tool built right into it, the Application Center load test, which is really great. I use it all the time. So worth doing a little bit of load testing on your own, and pretty easy to do as well.
One of the things I'll add on the architecture side is up on MSDN, and this is still in its maturation process right now. There's a prescriptive architecture guidance site, and we're building these out in modules. And you ask a really good question. I take that question personally because I understand I understand what you're asking, right? You want the blueprint, and you want the numbers, and you want the code. And that's going to be an iterative process right now. I mean, a lot of these questions, that are being asked, there's some hardcore answers that we have to distill down, and ultimately that's what will drive that next super demo app. I think the Java Pet Store is a good one. It was a good response to show that we have a much better programmability model, and our stuff just works better. But that's great to fight between the Java community and the Microsoft developer. That really doesn't help you per se. And we're working on that. I guess that's the answer to my question. And I would go back to that PAG site repeatedly and also provide feedback on the types of things you're looking for. They did a great job on the data access piece, but you need the whole picture. And we are working on that.
Thank you.
I'm sorry to add one more plug there. Is that on MSDN, on building distributed applications with .NET, on that site, there's a set of performance comparisons that take a look at some of the architectural design choices that you can make, going from the way you access data, the way you manage transactions, and in the current there's some comparison of web service implementations as far as performance, as well as the current project that's being worked on that'll be released in a couple of weeks is a distribution comparison. And those comparisons look at different sizes of data, from returning, say, an integer to returning a set of customer rows to a lot of customer rows to returning, say, a few orders and their details or a lot of orders and their details. So that's an actual interesting comparison with the numbers to give you the impact of some design decisions.
I want to ask you and take an opportunity. What types of scenarios are you looking for? That's the other thing. The Java Pet Store is one scenario. It's fairly anemic in what it covers, and it's great being at TechEd and being at conferences and talking to customers, but that's something, and maybe you could tell us, or as the people come up to to the mic, what types of scenarios would you like to see get pushed down? Are you really struggling with the distributed problem? Are you struggling with the portal problem? Are you struggling with the reach problem? Are you struggling with web services? That's and if your answer is all of them.
I don't know if I feel qualified to answer that by myself. Yeah, but clearly web services, in addition to the stuff that the core Fisher Mather stuff was doing.
All right.
With reference to the hash that is appended when you enable view state MAC, is that the same hash that is used by forms authentication? This key, this machine key that has to be synchronized amongst web farm?
It is, I think it's called decryption key.
Because Eric Olson said that there's a machine key.
There is a machine key
element
tag
that has attributes for decryption and encryption.
Yeah, there's a machine key element, and on that element, I think there's something called decryption key. I think that's the one. If you're interested to see the gory details, including a little inline code snippet that will generate a key for you, I'll plug a paper or an article that I wrote on MSDN called "Taking a Byte Out of ASP.NET View State," and it goes into gory detail about everything you could ever want to know about view state, and then probably about 20% more. And near the end, there's a discussion of securing view state. The hash itself will secure it from being hacked. You can also further secure it to encrypt it so that it can't be sniffed as well.
My question and my concern is that if this extra step, this step of making sure that that key is identical amongst boxes in a web farm, means that that key is then stored clear text in web.config. Is that correct?
No, it's in machine config. You can't config it at the application level. So it's not in any folder that would be exposed as a website on your box. So that's pretty good. If you do not configure it the same, pages that post from one server, or served by one server and then post to another, the view state will be lost going from one to the other. So it's something you can't really live without, short of turning off the Mac, which would be an even worse idea.
I agree that from a functionality point of view that it's definitely not something you want to live without. I'm just making sure that I have the right arsenal to go to my security guy when my security guy says there's a key being stored in a clear text on a multiplicity of web servers. And the answer is that because it's in machine config, it is not accessible.
Well, somebody would have to be able to take control of your entire box to get to it, right? They wouldn't be able to get it.
Okay, and Eric suggested rotating that key and just making sure it's synchronized. To do that, is there any tools, or is it just a matter of building something that pushes that around? Just
building something that pushes around. Like the regular content replication that we can use in .NET apps, you can push a machine config file around as well.
Okay.
And just blast it out to your whole server. If you're using any kind of content replication on your servers, you just mark that thing to go as well.
And when dealing in a web garden situation, when you have a web garden on each box and a web farm, I assume that posting between web gardens would be the equivalent of going between?
It also uses the same key, I believe. Eric would know better than I, but I can't see that it could not use the same key.
So other than that, there's no gotchas in using web gardens as well?
Not that I'm aware of, nope.
Cool, thanks.
Hi, I have a question that's kind of a little bit abstract, probably be more applicable to plumbing guy.
Mr. Plumber.
But anybody can answer and chime in. From a high-level look at what's happening with passing around data, and the plumbing guy's talk on security was definitely welcome in the web services arena. We keep on adding more and more and more to this SOAP message in the XML document that keeps getting handed around. More logic is being embedded in this message that's handed across the network, and therefore just the size of this packet keeps getting bigger and bigger and bigger. Now, if I'm scaling out to reach, if I'm dealing with 10 clients, it's one thing. 100, 1,000, 10,000. Nice talk this afternoon on IIS 6 and performance there. He was discussing most of their testing does not happen unless they have gigabit cards in their boxes, 1 per gig of memory. And they don't go anything lower than that because they max out the card, and they max it out easily. My question to you is there anything, any kind of talks from a level of getting standards to take a look at compression of SOAP messages and the XML information to get it back down reasonable so I'm not passing around? I mean, it's like deflate compression on HTTP 1.1. I can take a 100K document and translate it down to 9K, pass it, you know, respectively in the time that it takes, you know, to pass out. I can now pass out 9 more messages and still be faster than I was passing around the original message. What is your go?
Yeah. I actually have a personal interest in this because I worked on this problem in the previous team before I joined my current team. The idea is actually pretty simple to solve. And there are different algorithms that you can go after. A lot of people look at the canonicalization problem about if you are going to compress this XML, what do you want to compress? And you know, are we ripping out comments? Are we going to use schema to possibly get some compression and to get some faster parsing? My point here is that it's not rocket science. There are different choices that have to be made. The thing that's going to drive this is going to be a standard that's set forward. Unfortunately, this wasn't one of the low-hanging fruit items during the maturation process. So, you know, we focused on SOAP, we focused on WSDL, focused on UDDI. We're focusing on security heads down right now. The compression piece is something that we're looking at, and it's just going to be a matter of finding that sweet spot in the spec that the rest of the development community, and you know, we're not going to own this. It's just going to be something that we'll end up proposing, and it'll go through the standard, the traditional standards process. But it really comes down to finding that algorithm that's going to make everyone happy.
My concern is primarily due to wireless clients, because I've been, you know, seeing some demonstrations and presentations on mobile small clients, Pocket SOAP, pretty neat problem. Try to pass it over a CDMA or a CDPD link.
Right.
And you'll be wanting to go get coffee, come back, have a donut, and you might get it back by that time when you're ready to use it. Not very usable in its current format, but passing something like, you know, a deflated, compressed HTTP 1.1, I can pass that down to a client pretty fast. And so those are some of the concerns that being a mobile developer, you know, developing things for the clients, it's kind of not ready for prime time yet for those clients. And I was wondering when we could see that on the horizon, and if it's not a low-hanging fruit, when do you actually expect to see this get pushed up to where people are starting to measure ROI in terms of how much, you know, I've got to put out more boxes now because I've saturated what these boxes can do.
Right. Yeah, and I mean the reach problem. So you throw the curveball in there about the reach to the client. That's probably the thing most downstream right now, specifically with the group that I work on. And I can't speak for the mobile group and types of work that they're doing. I would see that this is going to be an iterative process. We're going to solve the standard messaging piece first, and then that'll be adapted to the specific reach and the ultimate client that's involved, whether it's the phone, PDA, some type of micro browser format.
We're going to have to stop the online discussions now as we're out of time, but I think as long as we can get people to stay around, we'd love to have you come on up and talk to us. Just before we do that, could we bring up the slide with the URLs on it? There's some places to go for more information. And then got one more request, is that on this panel, that you please fill out those review forms. We need the feedback on that. And if you can put in any information on the MSDN architecture fast track, write that in on the back of the review form, that would be fantastic. And then, so as we go on, why don't we just, I guess we'll be stopping the tape in a little while, and then having everyone come on up, and we'll just continue the discussions up here. Okay? Before we do that, I'd like to thank all of you for joining us here this afternoon, and I'd like to thank all the panelists.
Thank you.
Hello? Can you guys hear me?
Hi. Yes.
Hey, I went to a number of these presentations. I've seen a lot of stuff up here. And if I'm developing for the web, I've seen a totally rich object model that's happened in the middle tier. But if I look at it, what have I gotten? I mean, I've gotten a rich data model, or rich object model to work with my data, but I'm still getting data, and I'm just presenting that data, except maybe for that the remoting part of it. But overall, I mean, I've seen X views where all you're basically doing is SQL queries, I'm assuming. It's basically taking work out of the SQL Server box and pulling it into the middle tier, unless I'm mistaken. And I just wanted to understand what your thoughts were on, let's say 5-10 years down in the future. Do you guys see most of the stored proc work coming up into the middle tier and being done there, or is there a mix and match here? Because I wasn't sure.
So I think there's a mix and match. There's certainly processing that you want to do in the database because you're working directly with the data. If you're iteratively processing a bunch of data, you don't necessarily want to bring all of your records down to give everybody a 10% raise and then copy all of those back. It's easier done either declaratively in your statement or through processing on the server. Now, one of the things that we've announced for SQL Server is in the next release, we will be able to host the Common Language Runtime as the development environment within SQL Server, so you can write your stored procedures instead of in Transact SQL in any of your Common Language Runtime languages. So in fact, you can start adding real business logic and well-written components there. But there definitely is a trade-off between where your processing occurs that tends to happen because in most websites we're finding the database often becomes a bottleneck because the database is where all of your shared data lives. And if all of your different websites, all of your applications are trying to interact with that shared data, that obviously becomes a bottleneck. So there's ways to try to federate that data or partition that data. You can partition it, you can replicate it to try to make that data, more available. But quite often, the more work you can offload from the database, the quicker your overall web application becomes.
It's actually one of the benefits of taking your data and converting it to presentation and throwing away the data representation. Because then you can cache that guy and serve it from cache and not have to go out to the database and fetch it again. It's not possible in lots of applications, I know, but a lot of content on the web is very repetitive and lends itself to that.
Right. I mean, we just do a lot of stored proc work, and it's generally easier to do stuff right on the database, especially if you've just got one database. You're not going across databases or transactions. And every time I see us doing XPath queries and just getting into SQL type or data manipulation with update grams and diff grams, I just didn't know whether I should invest heavily into firing all the stored proc guys and hiring more developers or just waiting around and go out full circle.
So I think stored procs are definitely a great way to access and work with the data that is in the database. Now, there's a separate question, which is how much of the work is done in the database, which is the one you asked, and how much do you move out of the database into a logical tier or data tier or a separate tier. And that's a very interesting debate. And a lot of it, there's a lot of factors that figure into that. One of those is how shared is the data. You really don't want to replicate all of the data out if that, as a complete set of data, if the data is highly partitioned and questions that I'll be asking have no relation to questions that Susan's going to be asking. In that case, you might want to partition your data, like Hotmail, for instance, has partitioned data, and when I log in, it's going to route me to the database that has my data in it. Another thing to consider is, even if the data is not partitionable, like it's Amazon's catalog of all of their books and records and CDs and so forth, well, you can partition books from records from CDs, perhaps. but does my query to Amazon have any relationship to Eric's query to Amazon? If so, if there's a subset of data that we can cache, and we can work off of that cache set of data to give different presentations, then it makes sense to do that. But if I'm doing a context search on the text of different books that's stored off in some huge database, then the likelihood that my query is going to match Eric's is very low, and then you're going to want to not replicate the data but do the processing locally. So I think we're seeing more and more cases where, as you say, there's a mix of the two. You look for places where there's a lot of redundancy in the response, and then you want to cache the response that has the highest level of redundancy and in reuse and is the closest to what the user is actually going to see. So if everybody's going to be seeing the exact same page, you want to cache that page. If everyone's going to see a slightly different page, perhaps customized, but containing a subset of the same data, then you want to cache that subset of the data and regenerate it from that subset of data. So unfortunately, there's no easy, put all of your data in the database, all your processing there, replicate all of it in partitions or in replicated databases and so forth. But those are just some things to consider as you're thinking about building your applications.
Thank you.
If I can, and I realize you're talking primarily around a web, but even in a web scenario, you know, the further away from the user you push your logic, the less responsive their experience becomes, right? Which is, so I agree with everything you said, but I think that another factor is that, and conversely, the closer to the user you can push logic, the more responsive, richer, interactive, and dare I say fun, the experience becomes for the user, right? And so by saying, I'm going to put everything in the database, well, that means that for the user to ever find out if anything was good, bad, indifferent, any calculation, any new values, we have to go from the user to their terminal, to the web server, to the database, back. Right? So there's a lot of complete round tripping that has to occur in that architecture before the user can find out if anything was good or bad. And since no users really like that, what you end up doing is, of course, replicating the code further. You know, that same code that you wrote in your stored proc ends up getting replicated, whether you like it or not, out somewhere else closer to the user to give them a better experience, since then you end up with a synchronization problem too. Right. So, you know, it is a very challenging problem.
It's just that when you pull things into the middle tier, you need an intricate understanding of how the relational databases store their data. I mean, even if you've got a rich object model, you still need to know, hey, you got to put this child parent first, you know, figure all that out. And if you're going to abstract it to the point where you're pulling everything out into an object model, why not abstract it to the point where you don't really understand the relational model? Because if I still have to do that, I'd basically want the guys who write my stored procs writing the code in the middle tier, as opposed to having someone who doesn't really understand relational databases writing SQL-type code. And just because he's doing it in an XML view or XPath doesn't really change the fact that he needs to understand the layer below it.
Well, so if you throw objects into the mix, that changes things again, right? Because if you're truly creating an object model, it will be a good one, totally unlike your relational model. Right. Now, that doesn't always happen because a lot of people do this one-to-one mapping thing, but I mean, that's not right. And so your object model should be, in many cases, quite different from your relational model. And so you're absolutely right that there's this middle piece that's an object relational mapping layer that has to occur. And this does not rule out stored procs. Right? In fact, you should still use them. It's just they tend to get smaller because that mapping layer has to do more. And that mapping layer, I agree with you entirely, has to be written by people that have a solid understanding of the object or of the relational model, but it's a different skill set because they have to comprehend the object model too. Right? So they can't be just pure relational data experts. They have to have some decent understanding of what they're translating the data into so that they can provide it back up to the objects in a meaningful way.
So one of the things that we've done to facilitate the separation of the storage of data versus the presentation of data in ADO.NET is to provide the concept of a data set, which is sort of your generic representation of data in the presentation tier. And you might build something called a strongly typed data set, which does object wrappers over that, but not the business logic.
Right.
You might write your own business logics that populate themselves from that data set. But how that data set relates to the data in the database is entirely controlled through a separate component called the data adapter. And that data adapter uses commands both to populate the data set, which can be seen as the data underlying the objects, as well as to send changes from that made to that data set back to the database. And one of the reasons for explicitly exposing those commands to the programmer is to allow them to use stored procedures for that. So I can have my data in a data set. I can build my objects from that data, which is locally, it's very rich. I can have strong business objects written over that. I can interact with the data that way. And then when I call update on that data set, or actually on a data adapter passing in that data set, I can specify the stored procedures that are used to send those changes back. And so the stored procedures are going to pass as arguments the current values to those rows in the, or columns in the database table, and then my stored procedure can take that and apply that logic however it wants within my fiefdom, if you will, from the previous discussion. So I think that gives a very, very powerful way that you can maintain your stored procedure programmer's job security. But it allows you to, both for security reasons, for mapping reasons, for reasons of separate maintainability. Now I can change my back-end storage and change my stored procedures so that the same arguments are reflected in a new schema in my back-end. It gives you all of those great things.
Hey, thank you. I just had a comment. My real issue wasn't with job security. It was really with who do I educate, the middle tier guy or the database guy?
Yeah, sure. So I have a question there. So you're using SQL XML to do this work then, right? You're using
pretty much, yeah.
So the problem is that you now have SQL XML, but you don't have a programming model for the business objects that you want to drive that data. Right?
Right.
Okay. I understand this problem. I just want to give feedback to the product group to say, you know.
Thank you, guys.
All right.
We're overlapping on some speakers' tech rehearsal time for tomorrow, so they've asked us to actually, and I think our group is small enough now that if we could just move to the back, we'll just take the microphones off, and if we can just move to the back of the room and let them continue with the tech rehearsal here, then we can continue.